Welcome to Ask and Learn.
We are given a differential equation and a rough sketch of the slope field of this equation. We are asked to find solutions with given initial values and to find all equilibrium solutions. The equation we're given is y prime equals tangent of 1/2 pi y, and the associated slope field is given to the right. In part A, we are asked to find the graphs of the solutions with the given initial value conditions. In part I of y0 equals 1. I'll draw this graph in black. We know that this graph will have a point at 0, 1, and roughly following the slopes of the slope graph to get slope field, we get this sort of a parabola on its side, but it rises more steeply. In fact, it has two asymptotes, one at y equals 0 and one at y equals 2. And we see that this graph does not have any values in the first quadrant, third quadrant, or fourth quadrant. Next, in part 2, we asked to find the solution with initial value y0 equals 0.2. Now graph this in red. So we know we have points at 0, 0.2, near the origin. And again, following the slope field, nearly parallel, we get another parabola-like function, sort of a horseshoe shape, which has asymptotes at y equals 0 and y equals 2. And it looks a lot like the graph from part I, part 1, except it's been shifted over by a few units. It's by 0.2 units, hard to say. In part 3, we are asked to find the solution with initial value y0 equals 2. I'll graph this in green, so we know we have a point at 0, 2. And we see that following the slope field, this is simply a horizontal line, y equals 2. In part 4, we're asked to find the solution with initial value y of 1 equals 3. I'll graph this again in black. So we have that 1, 3 lies on the curve. And following the slope field, we again have a sort of horseshoe-shaped graph, which has asymptotes this time at y equals 2 and y equals 4. And you can see that this is something like a translation of the graphs from parts 1 and 2, but further up the y-axis, and also further to the right. In part B, we are asked to find all equilibrium solutions of this equation. Looking at the slope field, we do see horizontal asymptotes at 0, y equals 2, and y equals 4. So we might guess that all equilibrium solutions are the set of all horizontal lines which have form y equals 2k for some integer k, so it's y equals some even number. To prove this, we can use the equation. So supposing that y equals c is an equilibrium solution for some c in the real numbers, then we have that y prime is of course going to be 0, and we have that a function tangent of 1/2 pi y, or tangent of pi over 2c, is going to be equal to y prime, so it'll be equal to 0, and we know that tangent is 0 whenever sine is 0, so this is whenever our expression inside pi over 2c is equal to sine is 0 for any integer multiple of pi, and solving for c, we get that c is equal to 2n. So we have shown that if we have an equilibrium solution, then that solution must have the form y equals 2n for some n in the integers. To show that this is indeed an equilibrium solution, we'll plug this into our equation. So we assume that y equals 2n. This is we're taking this as a possible solution. We get that y prime is equal to 0, and we get the tangent of pi over 2 times y, which is 2n. This is equal to tangent of n pi, which we know is 0, and therefore is equal to y prime. So we see that the set of equilibrium solutions of y prime equals tangent of pi over 2y is the set of all functions y equals 2n, where n is an element of the integers.